Hi. In this example, we're going to solve this third order homogeneous differential equation. And also we know that it's linear and all coefficients are constants. To solve this, we have to start with forming our auxiliary equation. In our first step, the auxiliary equation for this will be m cubed, right? Because we have nothing here. It's m cubed plus 3 times m squared minus 4 times m to the power 0, because this y here is not differentiated here. So that's equal to 0. This is a cubic equation, right? To solve this cubic equation, the first method we have to use is, what is it? Factorization, right? To solve this equation by factorization, we just look for one of the solutions as one factor of this constant term, right? And we are hoping that one of the roots of this cubic equation must be, if one of the roots are whole number or integer, then it must be either positive or negative 1, or positive and negative 2, or positive and negative 4. These are all possible factors of 4, right? Starting from the first one, the simplest one, that is 1 here. If I substitute 1, let's say if m equals 1, and substitute this value into the equation, here we have 1 cubed, that is 1. 3 times 1 squared, that is 3, minus 4, that's equal to 0. And 0 is identically equal to 0. That means that 1 is one of the roots of this equation, right? That means that by using actually factor theorem, we can write this expression as m minus 1 times, what is it? Here we have something, and here we have quadratic expression on the right hand side equals 0, right? And to find this expression, this quadratic expression, I need to divide this polynomial by this polynomial, right? By long division. So here we have m cubed plus 3m squared minus 4. What we have here? 3, and is divided by, what is it? M minus 1. M cubed is divided by m, that is m squared, and multiplied back, m squared times m, that is m cubed, m squared times negative 1, minus m squared. And if you subtract this, that is equal to 0. 3 minus 1, that is 4m squared minus 4. Now we'll continue. 4m squared is divided by m is equal to, what is it? Plus 4m. 4m times m, that is 4m squared minus 4m, right? If we subtract this, if we have, what is it? It is negative 4 minus 4m, that's equal to 4m minus 4. Okay. Still, we can divide this because the degree of this polynomial is greater than or equal to the degree of this polynomial. So division is possible. 4m is divided by m, that's equal to 4. And 4 times m, that is 4m. 4 times negative 1, that is negative 4. And the same expression, if you subtract, you get 0. So that means that here we have this expression, m squared plus 4m plus 4, right? Or if you just factorize this completely, we get this m plus 1 times m plus 2 squared, that's equal to 0. So algebraic multiplicity of this root is equal to 2, right? So that means that the first root is m sub 1 equals, actually here, not plus, it is minus, right, is equal to 1, m sub 2, and m sub 3 is equal to minus 2. So now, if you just write corresponding fundamental, or the solutions, then y, the first particular solution would be e to the power x. The second one would be e to the power minus 2x, right? And now we know that To get the y3, we should just multiply this by x. How do you know that? If you just look for this solution as u times y sub 2 and substitute here and solve this, you get x times e to the power minus 2x. So the general solution to this differential equation would be y of x is equal to all linear combinations of this fundamental set of these solutions, right? So that is c sub 1 e to the power x plus c sub 2 e to the power minus 2x plus c sub 3. Here we have c sub 3 times, that is x e to the power negative 2x. Okay,